Hey everyone, and welcome back to the channel. Today, we're going to talk about something you're doing right now without even thinking about it. You're breathing, and with every breath, you're taking in one of the most vital, fascinating, and surprisingly violent elements in the universe: oxygen. We take it for granted, right? It's just air. But have you ever stopped to think about what oxygen actually is, where it came from, and what our world would be like without it? Stick around, because the story of oxygen is an epic tale of cosmic creation, planetary transformation, and the very essence of life itself. Let's start at the very beginning. Not the beginning of Earth, but the beginning of the universe. Right after the Big Bang, there was no oxygen. The early universe was pretty much just hydrogen and helium, the simplest elements. So, where did our precious O2 come from? The answer is stars. Deep inside the fiery cores of massive stars, intense pressure and heat force lighter elements to fuse together, creating heavier ones. This process, called nucleosynthesis, is a cosmic alchemy, and it's how oxygen is born. When these giant stars reach the end of their lives, they explode in spectacular supernovas, scattering newly forged elements like oxygen across the galaxy. That stardust, rich with oxygen, eventually clumped together to form new star systems, including our own. So, literally, the oxygen you're breathing right now was cooked up in the heart of a long-dead star. We are all made of stardust. Pretty cool, huh? Now, let's fast forward to early Earth. Our planet formed about 4.5 billion years ago, but the atmosphere was nothing like it is today. It was a toxic mix of methane, ammonia, and carbon dioxide. There was virtually no free oxygen to breathe. So, how did we get from a poisonous wasteland to the breathable blue planet we know and love? The credit goes to some tiny, unsung heroes, cyanobacteria. These microscopic organisms were some of the first life forms on Earth, and they figured out a revolutionary trick: photosynthesis. They learned to use sunlight to convert carbon dioxide and water into energy, and as a waste product, they released oxygen. For millions of years, these tiny bacteria pumped out oxygen, but it didn't immediately fill the atmosphere. Instead, it first reacted with all the iron dissolved in the oceans. This created massive rust deposits, which you can still see today as banded iron formations in ancient rock layers around the world. It's like the entire planet was rusting. Only after most of the iron was used up could oxygen finally start building up in the atmosphere. This event, which happened about 2.4 billion years ago, is called the Great Oxidation Event. And let me tell you, it was anything but great for the life that existed at the time. For the anaerobic organisms that thrived in the oxygen-free environment, this new gas was a deadly poison. The Great Oxidation Event caused one of the biggest mass extinctions in Earth's history, wiping out a huge portion of life. It's a powerful reminder that one organism's trash is another's treasure. Oxygen, the waste product of cyanobacteria, became the key that would unlock a whole new, more complex chapter of life. With oxygen in the air, life could get bigger and more energetic. Oxygen is a fantastic fuel. When we breathe, oxygen travels to our cells and participates in a process called cellular respiration. Think of it as a tiny, controlled fire happening inside every one of your cells. It breaks down the food we eat, like sugars, and releases a massive amount of energy. This energy, stored in a molecule called ATP, powers everything you do from thinking and moving to just keeping your heart beating. Life that doesn't use oxygen can't generate nearly as much energy, which is why oxygen-breathing organisms were able to evolve into the large, complex creatures we see today, including us. Oxygen does more than just let us breathe. High up in the atmosphere, about 15 to 30 kilometers above the surface, oxygen molecules get zapped by the sun's ultraviolet radiation. This energy splits the O2 molecules and they reform into O3, which you might know better as ozone. The ozone layer acts as Earth's sunscreen, absorbing most of the harmful UV radiation from the sun. Without it, life on land would be almost impossible. So, oxygen not only gives us the energy to live, but also provides the shield that protects us. But here's the paradox of oxygen. The very thing that gives us life is also slowly destroying us. Oxygen is incredibly reactive. It loves to steal electrons from other molecules in a process called oxidation. You see this everywhere. A sliced apple turns brown, iron rusts, a fire burns, that's all oxidation. The same process happens inside our bodies. These reactions create unstable molecules called free radicals, which can damage our cells, our DNA, and contribute to aging and disease. Our bodies have sophisticated antioxidant systems to fight this damage, but it's a constant battle. The very element that powers our existence is also a source of our slow decay. It's a fascinating trade-off, isn't it? Let's think about what life would be like with more or less oxygen. During the Carboniferous period, about 300 million years ago, oxygen levels were as high as 35% compared to today's 21%. This superoxygenated atmosphere allowed insects to grow to terrifying sizes. We're talking dragonflies with the wingspan of a hawk and millipedes the length of a car. Why? Because insects breathe through tiny tubes in their bodies, and higher oxygen concentration allowed it to diffuse further, supporting larger bodies. It also made the world incredibly flammable. Wildfires would have been massive and frequent. Conversely, if oxygen levels dropped significantly, say to 15%, we'd have a hard time. We would feel constantly out of breath, especially at higher altitudes. Complex life would struggle, and a simple fire would be difficult to even start. Our entire planet's ecosystem is finely tuned to this 21% balance. Today, we're facing new challenges related to oxygen, not in the air we breathe, but in our oceans. Climate change and pollution are leading to the expansion of ocean dead zones, areas with such low oxygen levels that fish and other marine life can't survive. This process, called deoxygenation, is a serious threat to marine ecosystems that we depend on for food and a stable climate. It's a stark reminder that the balance of oxygen is delicate both on land and in the sea. So, the next time you take a deep breath, I hope you'll think about its incredible journey from the fiery heart of a star, through a planetary transformation that poisoned the old world to create a new one, to the complex dance of life and decay happening inside your own cells. Oxygen is so much more than just a gas. It's a cosmic traveler, a world builder, a life giver, and a slow, steady destroyer all at once. It's the silent, invisible force that connects us all to the universe and to the very first life on our planet. Thanks so much for watching. If you found this journey into the story of oxygen interesting, please hit that like button and subscribe for more deep dives into the amazing science that surrounds us every day. But let me know in the comments what element you'd like to explore next. Until then, breathe deep and stay curious. See you in the next video.